the other guy speaking
Máte
next
vypnuté
door.
mikrofony. You have the mics turned off.
Veronica, you have a very strong feedback. I don't know why. Okay. So hello, everyone. Welcome to tonight's event under the name Machine Archaeology. It is an event connected to the opening of artistic residency in collaboration with the Goethe-Institut and the Slovak Design Center and our festival Sensorium that deals with artistic exploration and critical thinking on the topic of robotics, our relationship to robotics, and especially the context of youth and artificial intelligence. My name is Lucia Dubacová, and I am the co-founder of the Sensorium Festival, which deals with the topics of art, science, and technology. It is based in Slovakia, in Bratislava, and it's been running for the past 5 years. I am really happy that our invitation for tonight accepted intermediate artist Ralph Becker. Welcome. And also Theo Jansen, who will join us a little bit later on. You will first see his documentary videos where he explains a bit about his work, and then he will join us for discussion at 7. And I would also like to welcome Markus Huber, the director of the Goethe-Institut Bratislava, who also made this event and the whole residency possible. So welcome everybody. In the first part of this online event, we will first hear an introduction from Markus, who will tell us a bit about the whole residency program and the generation algorithm project that is run by the Central Goethe Institute. Afterwards, we will hear a presentation from Ralph Becker, followed by documentary videos about the strand-based of Theo Jansen. And shortly after 7, probably around 7:10 or 7:15, we will transition into a discussion, which will be also joined by the resident artists who are here with us, Richard Guzmán, Emma Záhradníková, and Tomáš Danielis. So welcome, everyone. Also, I would like to welcome all the guests. We are really happy that you created this time and that you could join us. We will also run a round of questions and answers at the end of the discussion. So you can either ask a question live through the video call, or you can always type your question into the chat. We will be collecting all your questions, and then we will be translating them to the panel. So welcome everybody, and I would like to give the words to Markus Huber from Goethe-Institut.
Thank you, Lucia, and welcome and a warm welcome to all guests and all out there, the audiences. I shortly will introduce a little bit about the framework of this residency program, and then we can directly jump into the discussion between the artists. So the generation algorithm is a 2 years Europe-wide program of Goethe-Institut that is dealing with artificial intelligence and robotics. And I shortly will introduce a little bit to it. A robot must not injure a human being. He has to obey the commands of humans. A robot has to protect its own existence as long as this does not conflict with rule 1 or 2. This is how the Russian science fiction author Isaac Asimov formulated the robot laws in 1942. Asimov was convinced that intelligent machines would be present in people's everyday life in the future and even be superior to people, and that such laws would therefore be necessary. Now it seems for this first time humans have the technological knowledge and the tools to turn this science fiction into reality. The first driverless cars are being tested on the highways. Algorithms conduct stock market transactions, androids welcome us in hotel lobbies, and the Internet of Things is transforming entire cities into the Internet of Things and intelligent machines. Robots have left the factories of industrial production, and we encounter them more and more in our everyday life. This, of course, raises questions about how we deal with an increasingly intelligent, autonomous, and self-learning object world. Today, that said, we set the course for the next generation, the generation algorithm, the younger generation, and their everyday handling of algorithms. What will the reality of their lives look like? In what directions will artificial intelligence develop in the next years, and how can each and every individual influence these developments? These and other questions are explored by different formats within the framework of the generation algorithm, and the robot residency, of course, is one of it. So what is this robot residency program? Since June 2020, 2 Now robots have been touring Europe as part of this generation algorithm project, and they will continue to do so until summer 2021. The 2 humanoid robots have been prepared and programmed for their journey with somehow their first skills. They can now introduce themselves, which might only be a simulation of good manners, who knows. With this basic programming, they start their 1-year journey, and at various locations in Europe, they will touch down for residency. Artists, scientists, coders, and cultural practitioners are invited to work with these robots. And at each stop, the robot will learn something, or maybe unlearn something, or a precondition. So we are very happy to kick off this residency program with this evening and with this discussion with 2 esteemed guests. And I'm very happy and thankful for the partners, the Sensorium Festival and the Slovak Design Center. And I'm very much looking forward to this residency program. And I will leave the screen to Lucia, who will moderate this opening event and introduce our esteemed guests. Thank you very much.
Thank you very much, Marcus, for a nice introduction. We still have many people coming in, so I'm doing my best to multitask. So this is the moment when I would like to invite Ralph Becker. So hello, Ralph. Thank you very much for accepting our invitation. So Ralph Becker, many of you, as I see, also hello. I'm really happy to see here many previous attendees of the festival, many people who we know each other personally. That's really nice to be connected in this time of isolation. So I believe many of you know Ralph's work, which is mainly communicated through installations and machines that explore the fundamental mechanisms of new media and technology. I will leave most of the presentation of your work to you, Ralph. So welcome, and this is your work.
Thank you, Lucia, and thanks to Goethe-Institut and everyone for having me here and for the invitation. And I will share my screen. Hope it host has disabled participant screen sharing. You have to enable screen sharing for me, I guess. But maybe I can, while you do that, I can.
It should work now.
Ah, all right. Yeah, I was really excited about the term or the title that you gave that panel called Machine Archaeology. So I guess in a way you expect me to talk also a little bit about the past, and so and my work is also a lot based on inspecting kind of the history of machines or looking into the inner workings of machines and technology, maybe in general. And so I would like to start like with a short excursion into the autonomy of the digital, I would call it. So if you ask people or like a general audience or especially mathematicians and computer scientists, so they would come up like with this kind of very edgy definition of what the digital looks like. So very edgy lines, and there's a 0 and a 1 and nothing in between. But if you look into the real world and ask an engineer, he would say, or she would say, look, it's not that edgy. It's not, there's something in between it, and it needs some time for a signal kind of to go from 0 to 1 or back to 0. And the engineer has also quite some terms for this symptoms of the digital that kind of gets executed or implemented into the physical world. And I started like to look into like where kind of the origin of the digital methodology lies, and then you come across the cybernetic movement in the 1940s, like driven especially from Norbert Wiener, who was working on machines that track planes and to build machines, self-regulating gun directors. So it was amplified by war technology. And Norbert Wiener called this time when a signal switches from 1 to 0, or when it's kind of in between, the time of non-reality. Kind of when, if you imagine like you have now a digital CPU which switches millions of times per second. So there's always like this short time frames when the signal is not steady. So when the machine is basically in an unstable, undecided state or in a passage. And Julian Bigelow, also one member of the cybernetic movement in the 40s, called this the forbidden ground. So build the machines in a way that there will never something, a value or anything will be assigned to these thresholds. And this was kind of like an agreement that our technology is kind of based on, in order to eliminate basically the noisiness of the world and to enable communication and to enable computation as we know it today. And in a way, for me, this has become like the interesting part. So the interesting part of my research. I won't read that. Maybe you can read it while I'm talking a little bit. So, but this process of dematerialization of mathematical thinking into machines and formal systems was kind of very central for my research. And in a way, you could say that, like, if there would not be like a noisy, fluctuating, disturbing physical world, then we wouldn't need the digital methodology. So if you need noise, you need a fluctuating world in order to have a digital. So they need each other in a way. And I would like to take you on a quick trip into the machine. And so one thing that I already mentioned, and which is maybe also like an archaeological strategy, like to look into the deep space or the internals of these machines. And so this project that I'm going to show you started actually with a reading of a little text by Leibniz, who said, let us pretend that there was a machine which was constructed in such a way as to give rise to thinking, sensing, and having perceptions. You could imagine it expanded in size so that you could go inside it, like going into a mill. On this assumption, your tour inside it would show you the working parts pushing each other, but never anything which could explain a perception. So this was for me kind of like an initial moment for a thought experiment, like of imagining going into the internals of the machine, kind of to go in these kind of CPUs and to have a completely different perception of the digital, not looking at the screens, but looking at the internals of the machine. Most of you probably know like this science fiction movie Tron, where kind of the protagonists kind of go inside the machine in order to fight the evil master control program. But for that project or that attempts, I kind of looked into the history of computation, and then you come, if you go deeper and deeper into it, you certainly arrive at the in the Victorian times and the Jacquard looms, like for me, the Jacquard loom, which has on one side in the back like punch cards with the programmed patterns, with the patterns that are weaved into the fabric or the carpet, and then you have matter running in the system, and there's some kind of output. So it's for me like the perfect example of a machine where kind of computation kind of happens in a physical manner at already in 1862, and so that's like and aesthetically also like a kind of an open system, in contrast or in respect to the quote of Leibniz that I mentioned. And one important idea that for me is quite important, or like it's like a poetic side on what computation is, like that basic computation is translating between difference in space, so like code are differences in space, difference in time, which is code, and to translate it into space, which is a display or a printout or memory in general. So and I like this, okay, that suddenly like the special component is coming into the system. This is the project that kind of was a result of that research process, which kind of took me also like 2 years or something, which is like a fully working mechanical but digital, not analog computational machine, which is based on a very simple idea of a rechnender Raum, which translates to something like computing space or calculating space, could be like the German term for cyberspace. And he proposed like that a system or a model of the universe which is not transmitting or transforming matter, but where actually only information is traveling and kind of creating new states of the world, which was also like a very strange ideological framing, but that was interesting for me to think computation as a spatial process, which is basically the same as maybe Game of Life that many of you know, or cellular automatons in general. And basically the machine, the picture that I showed is basically this algorithm translated into a three-dimensional process, which is like the underlying structure. Maybe showing a video over Zoom is always like a little bit frustrating in terms of quality. So I ask you maybe go to my website and have a better quality of the video. But one important aspect, and that's also something that I see kind of like a very important goal of, or a artistic question, is the idea of kind of opening black boxes. And Latour mentioned or talked about like the effect of black boxing, the way scientific and technological work is made invisible by its own success. When a machine runs efficiently, when a matter of fact is settled, one need focus only on its inputs and outputs and none of its internal complexity. Thus, paradoxically, the more science and technology succeeds, the more opaque and obscure they become. So this also questions like this paradox. On one side, we want machines and technologies that we can easily use, like having user interfaces that are self-explaining and help us to work efficiently. And on the other side, we want machines and tools and technology to be open, transparent, and that everyone can kind of participate in its development. And on like that's really difficult like to moderate between these two approaches. Maybe I skipped that talking about cybernetics. So I guess like all of you know about cybernetics, and they're like these and the history of it. I mentioned it briefly already in the beginning. There's like but feedback is like a basic principle of these machines. For example, there's like the positive feedback is when a system is kind of over-actuated and kind of oscillating until it breaks. Like here in a oscillator, when the bridge becomes an oscillator and suddenly kind of breaks away. And then the negative feedback that we use in many machines, like a system that tries to create an equilibrium, for instance, a thermostat, or a Segway that is a self-balancing device. And then another example of applied positive feedback are systems, are games. Like in Monopoly, at a certain point, like it have to its feedback process is initiated that the money runs into one person's pocket. Also, like a pandemic is a positive feedback, and maybe I mentioned already rockets and their guidance systems, and also in an example of a positive feedback is maybe the guitar feedback in general. All right, and I mean, one thing is like that in this machine that I showed before, there's like still like an algorithm that produces some kind of output, and it's not. And I was looking for different structures or for kind of ways of building machines that have a behavior which is not kind of encoded into a central program, like like a composition. So I wanted to have a system or to build machines that consist of many actors or agents, and through putting them together in dialogues that kind of produce a certain behavior. And in most cases, I would call it emergent behavior or self-organizing behavior. And the term emergent is probably something that is can be described as more than the sum of its parts. So if you have many agents and you look at one and you see, okay, that's not really interesting, but if you put them together in a larger, they kind of create a dynamic, something that is not visible or detectable in one of the entities. For instance, in birds, flocking of birds, or in crystallization processes, and in living organisms, and in many things, many other things. So I wanted to get kind of away from this distinction of there's a process which is kind of locked up in a machine, and then send the outcome of the process to a display, and so I wanted to make the process itself as something to dive into the process and make the process itself to a sculptural, kinetic, or an open system. And that's basically my strategy, like that emergent behavior, kind of designing, which is impossible, basically designing emergent behavior, or it feels like impossible. You can't design it, you have to experiment with it. and kind of to have that components of using certain structures combined with materials and matter, and give these things certain agency to create an emergent behavior. And I'll show you maybe like 2 or 3 examples. This is one early piece that tried to implement such a system, like where I have 100 actors that kind of sense attention in the system, and depending on certain on the tension or the changes in the system, they would react to it in order to create some kind of equilibrium or stability. But it was kind of like a constant repeating process to create this kind of stability. And maybe I go to the next, and you can check out the video online. But that's also, that was really for me like kind of a really important work, like to do that step from designing algorithms to designing basically emergent systems that kind of perform their behavior in space, and to eliminate like this, there's an inside and an outside. And one certain aspect that was kind of important to me, or that kind of I came across, was the role of noise in technology. So most people would say, yeah, noise is something that we want to eliminate. It's kind of distracting, something that we want to get rid of. So we want a clean signal in order to have a certain, I don't know, clarity or and precision in something. And everyone who has ever worked with electronics and technology, noise is always your enemy. You try to get rid of it, and it's always like painful. But there are systems or concepts where kind of noise, and I mentioned that already in the beginning, noise has a very elemental role. So noise can become kind of like an element, and creative element, or an enabling element, and some sort of a catalyst to create certain dynamics. And that has become like an interesting point for me to research. In this piece called Interface 1, I basically have an interconnected network of many agents that are kind of fed or activated by noise. And through that noisiness, kind of this noisy activity, or introducing a certain form of friction in the system starts to play out, like to enact its space or its certain movements. And this is like the fast forward or a time lapse of this system. And in order to get noise in the system, so I started to experiment with non-algorithmic sources for randomness. So I was looking at certain technologies to incorporate noise in my machines, and one was kind of picking up the totally random events by the sun activity, or the scattering of particles at the Earth's atmosphere, and that kind of come down as cosmic ray showers. And I use like this Geiger counters to pick up these signals and translate them into random numbers that I feed into the machine. And maybe I close up with the last piece that kind of is couple of years old, which kind of focused on complex systems and kind of and how we kind of usually try to understand complex systems. So this is a quote from the foreword of Ilya Prigogine and Isabel Stengler's book about that's called Order Out of Chaos, and they say, Alvin Toffler says, one of the most highly developed skills in contemporary Western civilization is dissection, the split up of problems into their smallest possible components. We are good at it, so good we often forget to put the pieces back together again. So they kind of try to pronounce or to speak out a critique of the scientific world, and that can be very, very efficient. This is the split up methodology, the split up of problems into their smallest possible components. We are good at it, so good we often forget to put the pieces back together again. So they kind of try to pronounce or to speak out a critique of the scientific world, and that can be very, very efficient. This is the split up methodology, the split up of problems into their smallest possible components. We are good at it, so good we often forget to put the pieces back together again. So they kind of try to pronounce or to speak out a critique of the scientific world, and that can be very, very efficient. This is the split up methodology, the split up of problems into their smallest possible components. We are good at it, so good we often forget to put the pieces back together again. So they kind of try to pronounce or to speak out a critique of the scientific world, and that can be very, very efficient. This is the split up methodology, the split up of problems into their smallest possible components. We are good at it, so good we often forget to put the pieces back together again. So they kind of try to pronounce or to speak out a critique of the scientific world, and that can be very, very efficient. Building the structure where problems into their smallest possible components. We are good at it, so good we often forget to put the pieces back together again.
You would see, okay, this one hits this one and that, but if you see it in a larger constellation, it becomes impossible to trace kind of it back to its origin. You would see, okay, this one hits this one and that, but if you see it in a larger constellation,
now we have the option either, I think, I don't know how much time I have left. Otherwise, we have now the option to have another project, or I would finish up at this point.
You have about 2 minutes. So I think there is space to show one more project.
All right. Okay, then that's maybe another forbidden ground that I want to show, because, like, you know, like from the scientific perspective, have another project, or I would the digital has no relation maybe to occult or magical thinking, but I came across this little writings from Robert Flatt, who kind of wrote collected a lot of old thinking, old technologies or principles, and this is like something called geomancy, like it's a deviation technology that's based on biological material, for instance stones. And I was looking through it, and then I was really thrilled how it's based on, you cast stones on the table, and then you have a certain technique, like of moving the things with your fingers to create after a certain rule system to create higher figures, and through manipulating these figures you can create some kind of a higher degree of knowledge or truth about the future. So it's basically like a machine that does predictions based on geological constellations connected to a question. And so I was playing with this idea and kind of built this apparatus, which is like basically a memory. So it's a memory that runs on very imprecise raw material, little stones, and these stones can be placed in this memory, and there's a little camera that tracks the stones, and there's a little suck mechanism that can pick it up and move it somewhere. So kind of to build like a computational system, like a contemporary idea, like a Turing machine, on these super fragile and yeah, not optimal material for digital procedures. And it's computing basically on this with this stones some very simple algorithm, which is a Turing machine, or two-dimensional Turing machine. And this is kind of always kind of operating at this threshold that I showed in the beginning, like if you have the 0 and the 1. So it's kind of always like, most of the time it's kind of in between and kind of creating this arrows, and the stone jumps off, and then the whole algorithmic structure is kind of corrupted. And so it's basically like an idea of, yeah, like some execution of a thought experiment, and kind of and on the other side, kind of building hybrids of magical devices, magical thinking, and let's say 20th century thinking. This is like a little time lapse of the process. Okay, I think I'm through with my presentation. I hope you found it interesting, and thank you very much.
Thank you very much, Ralph. It was super nice to see all the projects and to have them introduced. We will definitely go deeper into them during our discussion, and there will be space for questions. So I also encourage everyone to ask questions in the chat. Meanwhile, we will get back to them. And now we will switch to our video part, where we will show you 4 videos introducing the work of Theo Jansen. In the first one, you will see like a more atmospheric video of how the strand beasts look like, and in the following 3 videos, Theo will introduce how different parts of the machine work, and actually we will even discover how does the brain of the strand beast work. So I will now switch to the videos. Just give me a second.
You'll find in every strand beast a sort of backbone. And this backbone, it makes a circular movement like this. And this circular movement is transformed into a walking movement written down a pencil. And you see, as soon as the pencil is on the ground, it draws more or less a straight line. And that means that the animal, it stays on the same level. So it doesn't toss up and down like we all do. No, strand beasts, they always walk and they stay on the same level. And that's because of the shape of this curve with the flat bottom. Now, this shape of this curve is very much depending on the length of the tubes between the backbone and the pencil. If you have another proportion of length, you get a totally different curve down there. And when I started this, I didn't know which proportion of length I needed to get this curve here with the flat bottom. That's why I wrote a computer program for an Atari computer in 1990, a long time ago. And this computer could generate a curve with a given proportion of length. Now, you think that would be the solution, but there are so many possibilities that if the computer would let pass all the possibilities, it would be on for 100,000 years. That's why I needed the principle of evolution. Evolution doesn't come up with a solution which is most optimal, but you come there fast. Now, there were born 1,500 legs like this in the computer, and all these legs had different lengths of tubes, so you also get 1,500 different curves. And none of these curves is this curve. The chance is very small. But there are some of these curves, and they have a certain resemblance. So they have a slightly flat bottom. And those legs, they get the privilege to stay alive, and they get the privilege to multiply. That means that the tubes, they are copied and reassembled to 1,500 new combinations. So you could see this as the children of the selection. Now, this process of selection and reproduction went on for months, day and night, and in the end there came out 13 numbers out of the computer. And those are the numbers which determine this curve. And the strand beasts, they walk, in fact, already almost 30 years on a proportion of numbers. And you could see this as the genetic code of the strand beasts. Now, this here is the water feeler. So this tube here is vital for surviving on the beach. So it goes over the ground about this height, and it sucks in air all the time. And as soon as it arrives into the sea, it swallows the water and feels the resistance of the water, and then there should happen something. The animal has to run out of the sea again. Now, we're going to try the water feeler right now here. So we have a glass of water here. This is the sea. And if I put this in here, there should happen something here. Now, what can happen here is that I connect the layers with the water feeler. Let's see here. So as soon as I put this tube in the glass of water, you should hear the layers rattling. So I will connect it with the bottles, but first I put on some safety glasses. So the water feeler is pumping, And now the animal comes to the sea, and you hear the lyres rattling. And now it doesn't rattle. So it works. I'm so happy because it doesn't work all the time. See, this is connected with an air tube. And if I take out this, you see a small O-ring at the end. So this is a piston and you have a pump. Now these pumps, they are connected with the wings. The wings move in the wind and they pump air into soda bottles to high pressure. And you can use this pressure in case that the wind falls away on the beach. They still have a little bit of energy in their, what they call, wind stomach to move. For instance, if you connect a bottle with this tube, then this jumps out from the pressure. So imagine that you have a valve here which opens and this jumps out. You have a sort of muscle. A muscle is nothing but an object which becomes longer or shorter on command. And the command is given by the valve. If it opens, this becomes longer. Now, the valve you could see as a nerve cell. And I have a nerve cell here. If I take up the upper part and I blow air in here, the air goes in here and comes out of here. So this is a connection. But if I push in this piston here, it's blocked. So this is nothing but a valve. Open, close. Now the valve is operated by a sort of small muscle. So if I blow air in here, it blocks here, so no air comes out of here. So if you see this as the output and this is the input, the output is opposite from the input. Now I know when you use words like output and input, people tend to turn their back to me. I will be very clear for you. If you see this as a person, and this is the mouth, and this is the ear, the mouth says the opposite from what it hears. So if it hears there's air, the mouth says, no, there's no air. And that's why I call this a liar. It's a person who says the opposite from what it hears. Now, imagine that you are a liar, and Stephen, who is standing here behind the camera, is a liar.
Hi there.
And I'm a liar. And for instance, I say to Stephen, yes. What would you say?
No.
So you hear no, and what would you say? Yes. So I hear yes, and I say no. Now in this small conversation of liars, I changed my opinion. I started off with yes, and I ended up with no. And that's what you have with an uneven number of liars. So you have a so-called dynamic system, which changes all the time. Now, I have 3 liars here. So this is you, this is Stephen, and this is me. And let's see what these liars have to say to each other. They're saying yes and no, just like we did. And as you know, you can see a yes as a 1 and a no as a 0. You can switch zeros and ones with these liars just like in a computer. So what you see here is the beginning of the brain of the strand beasts. And brains turn out to be a very good weapon in evolution. So with the brains, they will survive a lot better on the beach.
Okay, so we are back to live. I hope that you could all see the video as well. I'm sorry for a bit of technical issues here and there. And I believe we should be now joined by Theo Jansen himself. Theo, can you hear us? I will ask to unmute. I think you will need to unmute your microphone.
Do you hear me now?
Perfect, yes.
Okay, great.
Hi Theo, welcome.
Thank you.
Thank you very much for joining us.
It's just a pleasure.
And so I would like to use this as a transition into our discussion. So
Yes.
I noticed there was already one question for Ralph. So maybe we will first answer that one, and then we can move on. So there's a question. Thank you. Could you please describe your process on how to judge what ideas are worth exploring and what criteria to look for? Also, when do you prefer emergence and chaos come into play? Should the mathematical model already be emergent, or is it enough if emergent behavior appears in the physical manifestation?
All right.
Oh, there's Ralph.
Hi, Theo.
Nice to meet you, Ralph.
Nice to meet you, Theo. I think that was directed to me, right, Lucia? Oh, it's a very, very difficult question, but there's a lot of experimenting involved. It's never that I have like something sketched out on the paper or in my head, and then it transforms into a machine or a thing like one-to-one. It's always like a lot of trial and error and trying and kind of there's a lot of experimenting involved in it, and often through that experiment I learn much more, and then project maybe changes into a different direction. But it's not like a classical, or it's also in engineering probably. I wanted to make a difference to engineering. Probably engineers work in the same way. But there's certainly some kind of goal or something that I'm looking for, but I'm also very flexible in kind of changing the ways how I want to achieve that.
Thank you, Ralph.
May I react to that?
Absolutely.
I think, well, engineers, they cannot permit themselves to go off their plan. And that's a big privilege of artists, that they might have a plan, and the next day they said, well, maybe I'm going to change the plan. And that they do every day. And an engineer is not allowed to do that, because he got paid for that, for building a bridge in a few years, and he has a plan and he cannot change the plan. And Ralph and I, we are changing the plan all the time. And I think it's evolution. You could see our ideas as a sort of mutation. Most mutations don't work. So most of our ideas, they look as genial ideas, but usually we come on a moment that we said, no, the material, what you're doing with your hand is telling me something else. And then you continue on the advices, in my case, on the advices of the tubes, and in Ralph, the advices of the objects, the electronics, and so on.
Thank you very much. I would like to just slightly divert because we have 3 more guests here, Richard, Emma, and Tomáš, who are participating on our residency with the Now robot, and they are working on a project. And I would love to encourage them to briefly explain to us what is the project going to be about. The residency only started this Monday, so it's very, very early stages. We just met with Now. He's a bit moody here and there. So yeah, there are some specifics points that the artists are looking at in their project. So maybe could you tell us a bit about that, and then maybe we continue the conversation in that direction.
Yeah, thank you. Maybe, Emma, may I speak now for ourselves, but for both? Okay. So I will speak also for Emma for now, and then I can leave word to her and then to Tomáš. We are came here to this project as an artist duo, and can I introduce ourselves as we can say conceptual artists, which are focused mainly, you can say, on the technological behalf. And in this project, we try to work with neo robots, and we want to have interaction with children from primary schools, and which are either focused on art education. And the basic idea is the project. It will be a game which will be the lead necessary to find out what it's like to be in the skin of the robot. And the project will set the task of teaching the robot how to be less human-like, the process of the dehumanization, and teaching a robot how to become human again. The process of his humanization. We will observe the ever-shrinking line between man and artificial intelligence, the humanization of the machine learning, as well as the limits of the technological possibilities of the humanoid machine. And I would like to make some additional statements which we have now, which we had completed during these days. In our project, I will characterize this as research and the art process together. I will not say it's like a pure art project, because it's like a combination. It's like a combination of this research and art. So it's something extraordinary in this case, as we used to work before in our works. But in this case, I think it will be much more interesting. So we will analyze the behavior of the children in their creative process. We let them to play the game with the robots, and we will have several groups with the children, and they will examine the human properties of the robot, which are limited by its technological and material properties. We want also the exchange the artificial intelligence of the robot with the human control, without the children knowing that the robot it's controlled by a human. The output will be a video and research which will reflect the issue of more deeply. Yeah, that's basically it. We speaking about this experiment, and we want to combine with a group of experts. This expert will be from sociological to scientists and pedagogical experts, which will help us to finalize this project. And also Tomáš, as an expert for the movement and performance art. Maybe you can help me with end this class.
Okay.
So hello, I'm Tomáš. Thank you for Ralph and Theo to fairly fascinating presentation. I very much like the humor and the overview of the problematic and the perspective. So I'm Tomáš. I participate on this project as someone who consults or who asks the questions about where the project heads, what is the idea, what is the semantics of the idea. I am originally choreographer and a dancer. So of course I deal with the questions of the nonverbal communication about how do we perceive each other, but also how we can perceive the machine, how we can somehow assign, or why we assign some kind of emotional relationship in the terms of animizing the object as a living being. What this actually really do. In my previous work, I focused, or I worked with social mechanics, particularly about the game theories and the dynamics of power. In a recent works, I'm focusing more on the questions of empathy. And in this particular project, I'm somehow the outside eye, but there is on one hand, this project inherently have all the questions from a technological side, like Ralph talked about the noise, about one and the zeros, and it's somehow the mechanics of the process of the machine. But on another hand, there is also the questions: what is the impact on us as human beings, and what does it mean in the terms of transformation of society and the transformations of a human being, whether towards the directions of humans somehow slightly becoming a cyborgs, or how does it transform the society with well-known questions of proposing the bigger social inequality. How does it change in the terms of developing single human beings or the groups of the human beings, and how somehow the humanity plug or unplug with machines and with the artificial intelligence, with the machines, how they change their own nature. So that's my approach from somehow from outside, or as a consultant for this project. So I don't know if you want to add anything to this.
Yeah, no, well, I think it's like we have very excited time to with these now robots. It's something very new for us, and we're looking forward to when we meet with a group of children. It will be also very nice input. I don't know like how it's for you, but I hope so. We share all these feelings together, and for now on, we start to have like very exciting time with that robot, and we are looking forward to how where our lead will lead us in the end. So I'm excited.
We are very happy to be part of the residence. Now our robot is great.
Now our robot is like very innocent and very easygoing. You can say child yes. Right now already, and we try to get some codes or some new lines to this to get inside of this robot. So we will see what will happen after that. Mm-hmm. So yeah.
Thank you very much for the introduction, so that now we all know. So yeah, I have actually a question, like generic question for all of you, and maybe now especially it would be interesting to hear from Theo and Ralph. So we had this whole discussion on Monday through the first meeting in this project about like what makes a robot or machine human-like, and who decides what are those human-like features. And actually we were also talking about the whole question of should robots and machines be more like humans, or actually the opposite, should they be very different from humans? And this is this I find the really beautiful part of your work, Theo, that actually you managed to put together these pieces of plastics, and we all see like these amazing creatures in them, and they're so alive. They are they have a whole character around them, I almost feel, when I see them. So I'm curious, how do you think about what these inanimate objects make us feel like when, or like, yeah, should they feel like they're alive? Should they feel like they're human or animal?
Yes, well, I think we should leave the human-centric point here. I think life is something which goes over whole nature. And the way I work is that I don't try to make them feel like lively animals or beautiful animals. I follow the same strategy as Ralph did. I just follow the experiments which I do every day. And that's the easiest thing with this kind of plastic tube. You can build something in a few hours, and then you can try something out. So you can try this mutation, and then you see something in there. So you get some advice, in fact, from the material itself, and then you follow up the advice, and then you get a very capricious path, which is hard to predict. And at the end of the process, I'm surprised myself how beautiful they became. Not that I tried to make them beautiful. I think it's because I did not try to make it feel alive. I think as soon as you try to make something which is human, or I don't think you will succeed in that. The thing is that you follow the nature of the material. And if you do that, then you do, in fact, the same thing as the whole evolution has done. For me, it's hard to mention an animal which is not fascinating to look at. I mean, if you look at a horse walking, you somehow read the millions of years of trial and error in this walking. And our eyes are very sensitive for that. And it is, for instance, my animals, because I wrote this computer program in an Atari computer in 1990, that the legs, they were developed in a genetic algorithm in a computer. So the legs are evolved in an evolutionary process, and that's why they look more or less like real animals' legs, not for reasons of beauty, but for reasons of mechanics. I think real animals' legs, they use in a certain way, and our eyes are very sensitive for animal movements, since in evolution, an animal could mean something to run away for, or something to eat. And so our eyes immediately recognize this evolved movement. And at the same time, you see just a bunch of tubes. And I think that contradiction somehow turns over a switch in our brain.
I think I want to.
Yeah, go ahead.
I want to add something. There's something. I mean, it's basically our brain that tries to understand it and then kind of to match it with something that we know and you know, like to see the human or the animal like in anything. You sometimes see faces in power plugs or whatever. So it's kind of a very basic mechanism of our brain to detect or to see things that we know in artificial things or and so on. And what are sometimes, or what is kind of also a very interesting effect, if you have, like there's these robots that try to be very humanoid, and they try and put more effort in it to make it human and to behave and to model the skin and the movement, and then they become really awkward. That's something that we know, like the uncanny valley. And on the other side, sometimes you have like the machines of Theo that don't want to be like an animal or you know, but we have, our brain is able like to detect from very rough materials and movements and kind of suddenly, I don't know, mirror what we understand as an animal in these movements. But that's something like the paradox. Sometimes if you try super hard to make something human-like or animal-like, they look strange and weird. And on the other side, sometimes like just like a few tubes that move in a certain rotation looks more organic or animalistic or human than, yeah, like the other extreme of the scale of robotics. And that's something I find interesting, how you can achieve like, and it's something that you don't want to achieve, as Theo said, but sometimes you don't try, but it feels like organic or life-like without actually intending it.
Thank you very much. I would just like to maybe remind also for those who didn't see the chat that I definitely encourage you to post questions. Also, if you turn on your cameras and you raise a hand, I will do my best to notice you, and we can have an actual conversation as much as possible through through the screen. I definitely encourage you to do so. We have a question from Marcus. It's written in the chat, but Marcus, please. I think it's you can also say it out loud.
Yes, I'll try to. Actually, it's a question about the binary system that we heard about, and it's kind of seemed to be the dominant framework. And you mentioned that we are somehow always obliged to think within the system, and it's very hard to leave also in an imaginary way the system of binary coding or of binary computation. At a certain point, there was this Russian development of the Saturn tertiary computer system, which was based on not on ones and zeros, but on -1, 0, and 1. I'm no computer scientist, but I just wonder and would like to ask both of you as artists, did you kind of work with that? Was that something that at a certain point was interesting for you, or how would you interpret that kind of a different, not binary computational system from which one could imagine also other forms of machines that we cannot imagine nowadays because we're so much caught in our binary logics?
Yeah, I'm a big fan of the Saturn project. I was really trying to put my head into these machines, but I started to imagine these machines in the beginning as something that have the states of true, false, and what could be the third state. So there was like imagining that there's maybe something like a maybe or undecided in these machines. But unfortunately, if you look further into it, it's just like it just replaces, like, adds another state to the system, and from a mathematical position, not really much changes. But one can say that, like, in this fight of these systems, let's say the binary system in the Western world and the trinary system in the Russian world, the trinary system has some advantages, kind of solving certain functions in a more in a quicker way, but it did not really have that philosophical implications that one would think on the first look at it. And I think it failed, or did not succeed, because building like this fundamental logical or memory cells is much more complicated than in the binary. Like if you have there's a transistor or building like a certain memory, so that worked better and easier with a transistor compared to building trinary memory elements. But I think there's like an interesting, like it can have an interesting philosophical connotation.
But this Russian system, was it in the 50s? That pneumatic system in the 50s, is that what you mean, Markus?
I'm actually not sure. 50s, 60s,
yeah, the 60s,
it was but it was kind of this Cold War thing, Russian trinary and the binary for the Western world.
Well, of course, there are more systems like that. I mean, if you take the DNA system, you have 4 digits, which works quite well as well, right? It's not bad. So I think you could have any thing, but I must say the binary system has something, some beauty in there, and but also sometimes it's too complicated. So I really came back from the binary system. So like I used to have a step counter in the past, which was based on a binary system, very complicated because you need a lot of bits and bytes, and nowadays it's just a pump, and every step the pump pumps a little bit of air into a soda bottle, so the pressure will rise, and as soon as the pressure in the bottle will exceed a certain level, you have taken a lot of steps, which is not very accurate, but very simple. So I'm going back to the analog system, you could say.
There's also this fuzzy logic, which was hyped in the 60s and 80s, like this having transitions between 0 and 1, and then compute with kind of these multi-valued systems. I'm not sure, but I think there was a brief time when that was kind of hyped, and in electronics were using it quite a lot. But actually, I find it interesting and important to look at these, let's say, at these strange moments in the history of technology and science, where maybe something emerged that was not successful in an economical terms, but maybe was very poetic or interesting and eye-opening and inspiring, also from an artistic perspective. That's something that I find always interesting, looking at these machines like the trinary logic.
Actually, Ralph, in your presentation, you mentioned the term black boxes. And when I think about how a regular person still nowadays sees a piece of technology that they use on a daily basis, it's more or less, we can say it's a black box for most of us who are not engineers or who are not computer scientists. So I'm wondering, how can we understand machines better, and actually who is it important for to understand machines better, and how does it influence our relationship with machines when we actually understand the mechanics behind it?
There's like the term empowerment, so it's kind of empowerment to know what's in it, and every child starts to do that. So so if the parents don't say no, but the natural way of child's approaching things is kind of to break it and to look into it, what's happening inside it, and it's something that kind of is now even forbidden if I buy a smartphone from Apple, so I'm not allowed to open it. So it's just I just own the surface of it and the case, but not kind of the knowledge. I remember in the GDR there was like if you bought a television, you got the complete plan of the television. So it's you own everything. The technical description, and you could repair it on your own. And so that's something, so sure, it's not really empowering like to give everyone like the fundamentals of computation. But I think at least there should be like systems should be open, and there should be a possibility for people to dig into it and to understand it. And at the same time also offering an easy, intuitive way of working with software or with tools and so on. And so, yeah, that's my opinion about black boxes, that we should continue opening them.
Thank you. Theo, has it changed somehow? How has it influenced your life with developing technology, with progressing technology, the fact that you are working with this with your artworks and that you are creating those systems in them?
The question is, how did it change my life, Joran?
Yeah, how has it or does it have any, do you think it has any impact on the way you live with technology?
Yes. Well, the thing is, as soon as you get into this imagination, to this you could say this addiction to think about these things and to try to make things. Of course, it influences your view on the world. On in fact, the view on my life. While working on that beach, working on new forms of life, and in the rain and in the clouds, and I feel very much connected with nature, you could say. And in fact, I'm surprised every day that I exist, and that I think it's such a miracle that I landed in this body of an ape, a monkey, which is being on that beach, and that I didn't. Somehow, all these questions keep me busy while working on evolution. So it's to me, it's a big miracle. I experience life as a big miracle every day, and of course, we all have this surprise somehow. But many times, also in my life, is so much ruled by the agendas that we have to take care of, all our duties, all our obligations. And being on that beach, I forget all those kind of things, and I feel like an Eskimo living 10,000 years ago. So I think working on my machines or my forms of life, it makes me more aware of my place in history and in evolution.
Thank you very much. We have a question from HAL 3000. So feel free to speak it out loud if that's possible.
Yeah, thank you for fascinating work, Theo. So I was wondering if you would program the computer program in like today's most advanced computers, what could it potentially change in your work?
A computer, you mean, or well, you could say I had a serious computer addiction in the 90s. So I was really into computers and working in a computer all day. Then in the evening, I realized, what have I done? today. I've been in a computer all day. So, and these were simulations. You could build Strand Beast in a computer. And of course, it goes very fast as well. But I think in my way so I left the computer. I really wanted to be outside again, outdoors, not in a house and at a computer screen. But I think I succeeded making a simulation in reality, because you could see a structure of tubes. You could see as a three-dimensional drawing, and a pencil line is just a tube. And you can build a tube also in a computer, but you can also just cut it off of a big tube, and then you have a tube in reality. So you can simulate a structure in reality, just like in a computer. The only thing is you can touch it. It's real virtual reality, you could say. And so it's computers are nice if you don't care about going out, but having really to touch reality, because all these are prototypes, and so it are trials just with your hands, which is just real, and but it's very similar to computer simulation. So I think I had the privilege that I could step out of the computer and go to reality and still simulate structures. I hope this is an answer to your question.
Yeah, thank you.
And
it's a struggle to step outside the computer world sometimes and bring it to the real world. So it's a nice idea, definitely.
Yeah, of course, you can bring things out of a computer in reality, like 3D printing or so. But the thing is that you could also simulate in reality. So the reality is a computer. That's what I want to say, that you don't need a computer. You can build things in reality and still simulate. So it doesn't have the end. It is the beginning, in fact.
Thank you.
We have one more question from Andreas.
Yeah, hello, Ralph. Hello, Theo.
Hello.
So I have a question from my point of view. I think calculating something always means to get control of something, right? And my question is, if losing control also as a creator, but also as observer of such a system, do you see any qualities in losing control again, or seeing something out of control?
Ralph?
I don't know. I guess also like with Theo's work, I mean, you give up control when you put these systems in the world, and there's a certain uncertainty kind of combined with, let's say, this analog or a mechanical algorithm. So there's actually, I don't see that there's like this pureness of computation that tries to predict something, or it's always predicting, but that being confronted with a physical world which has like always some unpredictable outcome, I would say.
But I think reality really forces you to not to follow your plans, and that's so the uncontrol. If you can control everything, then you follow your brain, you could say. And of course, our brains are beautiful, but our brains are all more or less the same. So something you have been thinking of, somebody else has been thinking of it as well. And so if you're, in my case, by the restriction of my material, I just restrict myself to these tubes, I'm forced to leave my ideas and follow more the advices of the tubes. So it's good to be able to control everything. But that's also an evolution. I mean, like every mutation, you could see as an uncontrolled thing, and it's a mistake, in fact. So a mutation is a mistake, and sometimes you are lucky with a mistake, which brings you in the right direction. So if you want to control everything, then of course, then you are an engineer. And of course, you should control everything. If you're gonna build a bridge somewhere, it shouldn't collapse. So you should be able to control everything. And that's our specialism and our privilege, that we don't have this responsibility. I'm so happy we don't have to build a bridge.
Yeah, sorry, can I have an additional question? Sorry, can you hear me?
Yes.
Yeah, regarding this, I was thinking that when you said that there is always something not under control, and shouldn't we then be afraid of the robots and of these machines, like not in the near future, but isn't there possibility that something can go wrong as not as what we predicted? And I would like to know if if we should be afraid of the machines or not, according to you.
Ralph, would you like to do that?
Really difficult question. I'm not afraid of machines, at least not of mine and not of Theo's, but certainly there are like this, if we look at the, let's say, high-tech or contemporary systems like machine learning systems, autonomous machines that do things in a complexity that we can't really follow anymore, then sure, there's something like, even if we usually tell the machines their goals, but there's always a certain, I don't know, moment of not freedom in the machines, but in their area or range of acting that is maybe not in our control anymore. But I'm not really like so I'm not really afraid of it. But I think that's maybe not, that's somehow present in it. Like when the complexity of these machines kind of rise exponentially at a certain point, there are things that we can't foresee anymore, whatever that is. So yeah.
Well, of course, we always think about a robot as a sort of human-like thing, right? But in fact, you should think of systems. I think they can be very dangerous, like the Facebook and the YouTube system. It's good. It has also good parts, but especially in sociology, that people, as soon as you look to a YouTube movie and you see something extreme, you're led to something more extreme, and people are spending a lot of time in front of their computers, and they're getting crazy, and that's happening already. And this is not a robot, but it's a system which is very dangerous, and we should stop it. I think Facebook should really be restricted in its possibilities somehow, without touching the freedom of opinion, of course, which is a contrary thing. But I think it's an example of what can go wrong with systems.
Don't you think it's already too late to have some
late, yes, yeah, but it was also hard to predict. I mean, who could think? We were in the 90s, we were thinking of robots, which armies of robots which would taken over humanity, but who could predict that such a innocent-looking thing like Facebook, and such a useful thing? I mean, lots of people having fun with it, that it could influence politics so badly, and so it's something we couldn't predict, and it's, of course, it's hard to stop. They try to stop. I mean, I think the the guys from all these companies, they try to become decent, but it's something you never know where it's going to end. So and maybe now there's already another system which has nothing to do with Facebook, but something else which develops itself against humanity.
May I add something to this context of social media? I have some small research to this, and as you said, Facebook or globally social media, Facebook, Instagram, Twitter, and etc. Has like very huge impact from the young people and like people like in global. According to this research, the people have a lot of depression because in all those pictures and all those status, as you can see, the people are presented not as they are currently normally living, but they are presented as they want to be seen. So that means that the people are seeing a different type of lifestyle of those people, and it's like all of this is like imaginary. It's imaginary of different type of lifestyles, and those people which are all seeing these scenarios, they start to be depression. Oh, they have so famous life. They have been there and there, or they have such a good mood in this photography. But also the photography looks. If you take a picture, the picture of what you see on the picture is like a moment of one second. So it doesn't mean these people which are smiling, which are happy, which are hugging each other. That doesn't mean like there was all the time like this kind of happiness. So that's why, according also to the study, that's why all these people have like kind of they are frustrating. They kind of the depression is also according to that, because they're thinking they're missing something according this storylines and everything. They must go there and they must see everything what's happening inside. So that's it.
One thing I want to add is like there's this interesting like that these social medias in one way kind of also need us in order to you know, like if you think about Instagram or something. So on the other side, they need us to train their system, you know, like there's this trend on one side, you need these likes for your self-confidence, or a lot of people needs it. And at the same time, you kind of, through that liking process, you kind of feed and teach this system. And so like there's like this term, like if you don't pay for it, you are the product, you know, like this idea.
Yeah. But it's dangerous, right? It's changing the world. Well, of course, all these things have their good parts and the bad parts, and that's with all the new things which are coming, and the new generations will be used to it, I guess.
So in terms of changing the world, we are slowly approaching the end of the session, but I have maybe the last question. Maybe there's also a chance for anyone who has the last question to write it now. So yeah, the world is changing. The world is changing really quickly, and especially in the context of the pandemic. Of course, we need to discuss that. I would like to ask maybe all of us, especially our guests, of course, how can art help us to bring more understanding into what technology is doing and what should it do or what could it do, especially now when everything happens through technology. And I often feel like we are on some kind of autopilot. You know, we need to talk to each other, we go to Zoom. We need to send something, we email, or we need to communicate something, we email, we chat. But rarely we think about like, what would be the best way to communicate the message? We rather do like the first thing we think of. So is there something art and artists can do to help us in this process?
Maybe I start. So I mean, maybe one thing that we already mentioned is like, you know, like if we leave that field to engineers, then we will have a problem. So I think or the wider range of society, or maybe a more diverse part of society should contribute to technology and to that world, and if it's by taking things apart or doing some things that are outside of economic efficiency, or to or building strange machines that live at the beaches and repair the landscape, or, you know, like for me that's something, there's a lot of outside of this engineering or industry thinking of technology that that artists should look at it and bring more diverse positions into it and so on.
I see art as a way to motivate us. I mean, why do we want to continue this world? I think we need to motivate ourselves to go on with the world, and since imagination is a part of art, and so to stimulate imagination with people, and that's what art can do. Because without imagination, there's nothing. I mean, we need our imagination still to experience the world where we're living in a happy way. And of course, you cannot make everybody happy, but you should make some reason, give somebody a reason to live, and give the world a reason to be there. And for me, the reason is that we must realize what a miracle we are living in. We don't need religion to see that the world is a miracle, and this realization that life is a miracle, I think art has the duty to bring to the people.
Thank you very much. We have, and this will be the last question as we are now over time. So George, hi George.
Where's George?
Hi. Sorry.
George Provenza.
Nice to hear from you. Yes, so what is your question?
So it's a silly question. Basically, as someone that always spends way too much time on a computer, I'm fascinated by that moment of transition from old school using BASIC and doing this simulations to just getting like hands on the physical world. Yeah, what advice would you have for someone that still spends too much time with simulations and like get a little bit of that fearlessness with getting hands dirty and making mistakes and breaking things?
Yeah, well, just I would say just start. Choose a basic material. For instance, I took tube as a material, but you could also use tea bags. So if you go to the shop, you buy 5 packages of tea bags and play with the tea bags for a month or two, and then do all kind of experiments with it. And then you will notice that the tea bags start talking to you. and they will give you advice, and that is the moment that you say, damn this computer, I throw it away, or I just use it for emails. George, did you hear was this an answer to your question?
Yes, thank you very much.
Okay, go to the shop and buy the tea bags then.
I think I'm going to do that right away. I have the same problem.
Okay.
2 little tea bags at home and at work. So thank you very much again for joining us, to our guests, to the Goethe-Institut for making all of this happen, to our artists, to my colleagues, and to the team in the background who helped us technically a lot. And we will do another conversation like this in January. The topic will be cyberfeminism. So we will announce it on social media, probably sometime at the beginning of the month. And really, thank you so much for a very interesting conversation. I hope everybody felt a bit enriched by the connection across countries, even though through a screen. And yeah, hope to see you in another conversation soon again. And Merry Christmas, Happy Holidays.
Yeah, thank you so much.
Thank you.
Thank you.
Thank you.
Okay, bye-bye.
Bye.
Bye-bye.
Bye-bye.